do is everyone have their calculator out and get it. You need a graphing calculator. Three. Now logs. We have trig and sinusoidal. I think after this one, 3. Yeah. Okay, so on your graphing calculator, one of the first steps that you need to do, yeah? You do circle? Yeah. Yeah, go ahead. Okay, so the first step is how do we know which regression is best, especially in the situation of a curved graph? If we have a curved graph, how do we know if we should use a cubic or quadratic? If these were just the points that I was given, just something like this, it would be hard to tell. It looks curved, looks like it should be either cubic or quadratic. So your calculator will do something. We're going to turn our diagnostics on, and it's going to give us an R-squared value. And that tells you how accurate the regression line is. Now, there's only one way to get that. So we're looking at the yellow sheet. Is you need to go second 0 to catalog. So this is where your catalog is, second 0. Now, you could either scroll down all the way to diagnostics on, or if you see the little, the D letter is x to the negative 1. You push that, you'll jump down to the D's. Or you could just scroll down. And we want to find diagnostics on. You are going to have to remember how to do this all on your own on your diploma. Okay? So, I don't know if I'm allowed in the gym even for diploma. Yeah, it's pretty strict. So you're like, as soon as you're walking in, I might say, yeah, I could try and remember that. Yeah. Okay, so let's go over that again. We're using the yellow sheet. So second 0 is where catalog is. We're going to the catalog. If you lose anything, you can find every single function in the calculator in there. So say everything. So say you forgot where to find n choose r. Okay, you could actually find everything in diagnostics if you forget, which is good. That's our catalog. I mean, in our catalog, not diagnostics. Okay, so once you get to diagnostics on, you want to push enter. Some feedback now. Okay, push enter. And enter again. So, we want to turn the diagnostics on because when we do a regression, for example, I have one here. What it's going to do is going to give you this R-squared value. So this R-squared value tells you the percent of points that are on the line. So it's usually as a decimal. If you get an R-squared of 1, that means 100% of the points are exactly on our regression line. So you really want a high, like 0.999 is almost perfect regression line, okay, for the equation of best fit. And so when we do cubic, so say if I did a quadratic regression for the whatever I have in my table, well, that was good too. Cubic. Okay, it'll give me an R. Okay, so I don't know what's in my tables right now. That's giving an R-squared value of 1 for every 1. But we're going to use that to compare. Okay, what's the best? Is it better to be cubic? Is it better to be quadratic or linear? So to compare them. So we're going to go through a little example here. So an R-value correlation coefficient indicates how good a match a regression equation is for the given data. So we're really looking at the R-squared value. It should be squared. Okay, the R-squared value of 0.5 is not very good. We want as close to 1 as we possibly can get. Okay, so let's look at an example. Oh, I want to delete these. Okay, so here let's look at this example. So let's review what we did yesterday. If we want to put our value or our stuff in a list, where do we go first? Stat, then we push edit, so number 1. How do we clear a list? Go up and push clear, and then back down again. Over, up, and then clear, and then back down again. So let's enter in this data. 0, 1, 2, 3, 4, 5, 6. And L2, 105. So if you just walked in, you need this yellow piece of paper. Okay, 121. And make sure, especially if this was a unit exam or diploma, that you double check everything you typed in. Because one number, one digit off, will affect your whole equation. Okay, so you want to make sure this matches your table. Okay, what's our next step? Zoom 9. So Zoom 9 is Zoom stat. So it actually will, so you can actually see everything. Now, is there anyone who can't see their dots? Okay, so if your plots are off. If you can't see them, your plots are off. So how do we do that? We go to easiest way, there's 2 ways. We can go to y equals. And this black line here, this plot has to be black. So if you push the up arrow and enter, that's an easy way to turn it on. Okay, the other way is second y equals. Well, you can also turn on your stat plots there. And you go, turn it on. Okay, so now if you've just did that, push Zoom 9 again, you should see your points. Does everyone have them now? Yeah? Okay, so does it look linear, quadratic, cubic? Kind of looks linear, so let's take a look. Now that our diagnostics are on, we can do a regression, a linear, a cubic, and a quadratic, and see which one gives the best R-squared value. Okay, so let's do this. Zoom. So where do we go next to do our regression? Not Zoom. Stat. Calc. Okay, let's start with linear. Number 4. And we don't want to put in y1 yet, so we'll just push enter. We want the R-squared value. Okay, so what's the R-squared value in this case? So 3 decimal places, 0.998. Okay, so now let's try the R-squared value for the quadratic. So we're going to go do a quadratic regression now. So stat over to calc. Now we want 5 for quadratic. And push enter, and what's our R-squared value? Even better. 0.999. Okay. You might help to take a picture here.
How do you go back and look at your previous equation?
Second enter. And then okay.
Oh, that was sick.
That was sick. You've seen that before, haven't you? It does, actually. It's because it's a camera. Okay, and the last one, now let's do a cubic regression. So same idea. Stat, calc, and number 6. Enter. Okay, so comparing the two, thank you. Who's the best regression to use? The cubic is better. Yeah, the cubic is better. It's pretty good. This is still really good. 0.0998 is a really good regression. So this data kind of follows all 3 really well. But the best regression would be cubic. You want as close to 1 as possible. Okay, so cubic, because it has the R-squared value, is closest to 1. Cubic has a R-squared value closest to 1. So today we're going to focus on curves, so quadratics and cubics. Let's look at the example on the next page. So I want to go through a couple other calculator steps. Delete. Okay. For each given situation, what would be the most appropriate regression? Calculate the regression for each equation. So we're just looking at this one. Morgan has a job that pays him $800 per month plus 10% commission on sales. Fill in the table to calculate Morgan's salary for each level of sales. So if he doesn't sell any money or sell anything, how much salary does he take home? 800. Okay. If he sells 1,000, how do we get his salary? I'm hearing things. You can yell. So times what? 1,000 times 0.1 is 10% sales. Plus the 800 would be 900. Okay, so $2,000 would be, so 2,000 times 0.1 plus the 800 gives you 1,000. Do we see a pattern here? So 1,100, 1,200, 13. Oh, it's 900.
Yeah.
Sorry. These are all hundreds, aren't they? Oh, except for that's 1,000. There you go. That's better. Okay, now what regression do you think is going to be best for this then? We don't know. Okay, so let's take a look. And let's go to stat and enter this in and figure it out. So can you figure out which regression's best? So we have to enter in our data. Zero. Oops. You guys you're so fast. Yeah, that's the problem. Too much Xbox. This is where those skills are going to come in. All that practice. Okay. So stat, edit. So you want to do all three. So number 4 first. Linear gives you an R² value of 1. That is perfect. You can't get better than 1. But let's double check if there's any other ones that are perfect. Stat. So for quadratic, oh, that's annoying. And cubic. Won't even do a cubic. Is that what I did? Yeah, it won't even do a cubic. So there's 2 really good ones. So what are the 2 regressions could you use? Linear or quadratic?
So I put it in my, I put it in the list, I pressed zoom 9. Can I see your graph for a second?
Oh yeah, sure. Zoom 9. Yeah? You don't get that?
Stat, calculator.
You don't get that?
I'm not getting one. I think I have the same thing.
Let's see. One of these values, you mean? Do you have all of them in? What are you not seeing?
I'm not getting one on my.
For quadratic?
Yeah, all quadratic.
So stat, or we actually did linear. So for linear you didn't get one? So then you might have typed in something had been typed in wrong. Did you guys get a R² value of 1 for quadratic? Yeah? The best one is linear in a situation like this. Even though they both have an R² value of 1, I would choose linear in this situation just because he has a base salary, right? And it's a rate that's going up, right? So it is a linear situation. So we're going to go with linear even though you could actually do both. No, you would not be wrong. If your R² value is 1, you're not wrong. Okay? So let's go with the linear one. Now we need to remember today how to put it in our Y1. So let's go back and do our linear regression. So stat edit to number 4.
I'm turning it on and doing everything.
Did you do the linear regression?
Yeah.
Oh, you've deleted your columns.
When?
See, there's no L1, L2.
Oh, I was in L4.
Yeah, L3 and 4. So you have to push clear, not delete.
Okay.
So second L1. So you have to insert them back. Second L1 or L2. It's easier. Yeah, here. So and then you need to insert second insert L1. So don't delete your columns. And so now you have to, yeah, so you deleted them before.
Okay.
So you don't clear, not delete. Okay? That's why. Okay, so linear. Now how do we want to put it? There's a way to put it into Y1 automatically. How do you put it into Y1 automatically? We did this yesterday. Okay, variables, so vars. We're putting into Y1. We want it. So when we go here, we don't push enter. We're going to do our linear regression. Don't push enter because I want to also put it into Y1. Okay, so it makes the regression equation, puts it into Y1. So vars, then Y vars, so over 1, then 1, so enter for function, and enter for Y1. And then enter again. So push enter. What that does, it puts your regression equation in Y1 for you. So you don't have to type it in there. Especially when there's a lot of decimals, that saves you so much work. Okay, questions? Yep. So you first go to stat, calc. I want to do a linear regression. Don't push enter. Why are we making a line? Because it's a line. Because the R² value equals 1. Yeah. And then just typing them in. Yeah, you could just type it in yourself. But when often our regression equation has like so many decimal places, right? And typing that out, if you type in one number wrong, then it's going to mess up your whole equation. So you want to be, so it's this way is a lot easier, especially if you have like this case, this is a really easy equation. You're probably not going to mess it up. So go ahead and type it in. But those ones that with like 0.0000259 x squared, that's going to be really particular, right? Okay, so again, vars for variables. We need y variables, so over 1, and then enter 3 times. Vars over to y variables, and then enter, enter, enter. Is yours different? Because your diagnostic's not on. So you have to do a second catalog to diagnostics on, and push enter. Okay? All right, so now define the regression equation, y equals 0.1x plus 800, which makes sense. Base salary of 100 and 0.1 times our sales. That's our linear regression equation. Oh, what would the quadratic be? We'd have to do the regression equation. Okay, delete that. What is Morgan's salary to be if his sales are 5,000? I'm going to teach you something new today. Okay? So x would be, so in your table, this is your x, this is your y. So x would be your sales, and y would be your salary. Okay? Something new today. So this question says, what is Morgan's salary? Would it be if he had, what is Morgan's salary if he has sales of 5,500? Okay, so do they give us x or y? The x value. So I'm going to show you a really easy way to solve for x on your, now that we have it in our graph. So go to graph. Now it has to be within our windows. And so if our 5,500 is not within our windows, we need to zoom out. Okay? But in this given situation, it probably is. We'll find out right away because it won't give you an answer if it's not within your windows. So how to find it on your calculator is push the trace button. Trace. Okay. Now, right now it tells you it's on your plot. We want to be on the equation. How you switch between equations is push the down arrow. So now at the very top, it should say it's on the graph. It's on y1. Yep, you got to practice, practice, practice. Okay? Now you don't have to. You could also just plug it into the equation, right? Once you get to know your calculator, this is way easier. Okay, now we type in 5,500 and push enter, and it gives you your y value. Okay, so we pushed trace. I had to push the down arrow to switch graphs. And then we typed it in, 5,500, enter. Switch. Oh, I spelled switch wrong. Switch. Graphs. Okay, so if you try and find it and you don't push the down arrow, what will happen is, if I push trace 5,500, oops, trace, yeah, is that what happened to you? You have to actually go down arrow because it doesn't register the plots. It won't do that. So you have to switch to the graph. You just push the number. So you can also go to value. Second calc number 1, value. But again, it might give you an issue. Well, that works. It didn't? Okay, did you try second trace then? Value 5,500. Yeah? Okay, let me take a look quickly. We need to all be on the same page. Is this one, second calc value. Okay, either or this would work. So maybe I'll stick, if this one seems easier. Okay, the other way is second calc and then value 5,500. That would work too. You don't have to worry about down arrow. Okay. Down arrow is easier. Okay, one more question on this. Yeah, it's a lot of, once you get it, it's easy. Just getting yourself used to the calculator. At what level of sales will Morgan's salary be 2,500? Caitlin? So do they give us the x or the y? They gave us the y value. In a linear equation, yes. In a quadratic or cubic, no. Okay, so our equation, guys, is linear. So would it be easy to put in y and solve for x in this case? Yeah. If it's a quadratic or cubic equation, it's a lot harder. So I'm just going to show you the steps given what if it was a lot harder. Okay, the steps would be, given another y value, you're going to go back to y equals. Because we have another y value. And we're going to type in that value they gave us. So in this case, 2,500. And graph. So what do you think we're going to do with these two values? Oh, can we not even see that? Do you have to zoom? Zoom out. So zoom 3. If it's linear, yes. If it's a cubic regression, no. Because you push enter? Did you push enter after? Yeah, so it won't zoom out unless you push enter. And then you compete. Okay? So we want to find the intersection of the two lines. I don't know if you can really see it. Second trace, remember doing this last year? 5, enter, 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 and it'll give you your solution. So we're doing the intersection of the two graphs. Oh, okay, we have to zoom out more. Zoom, 3, enter again. And there's the line. So now you have to be able to see your intersection. Second, it's a lot of calculator stuff in one day, hey? There you go. So x would be 17,000. So when you're given another y, you just plug it into y2. Yeah. Okay, so given a y value, go y2 equals 2,500. Second calc to find your intersection. Okay, so grab your notes. This was like, that was part of the lesson. But that was everything in one package.
Why can't I just plug it into the formula?
Okay, you can, Andrew. However, what if I gave you a question where your regression equation was something like this, and I gave you the y value, and I said, so what's x going to be? Then you would have to use your calculator and find intersection. Okay? In this situation, yes, you can just do this and solve for x. Absolutely. Old-fashioned is encouraged when it's a linear equation.
How many quadratics would we get?
Not that many.
A lot of clicking on the line.
Yeah? Intersection. That's it. That's it. Well, no, that's for after we get a regression equation, answering applications questions with that equation. Okay? All right, so let's skip that, and let's skip that. And let's go into a few things. Okay, so we're on page. Yeah, it's gonna be quick. We're gonna go through a lot pretty quickly. Okay, let's skip to question 2. Example 2. Okay, we've already went through a lot. Okay. So here, the regression equation is given to you, and you're given a graph. That's the equation for this graph of best fit. Okay, so it's talking, in this example, we have heart rate versus power. So it's a problem that we have an athlete's heart rate in beats per minute, and the x represents the power that outputs. Okay, how much power that's related to. So here's your graph. Guys, you're going to be asked to leave. I need your attention, okay? So this one, can you answer how we would answer this question here? Use the regression equation to estimate the athlete's heart rate when his power output is 310 watts. So what's x and what's y first? X is which one? The bottom, so that would be your power output. Okay, and what's y? Heart measured in beats per minute, heart rate. Okay, so it's looking for estimate the heart rate. So what's y when our x is 310? How do we use a regression equation to do that? Okay, it's the line of best fit, so we don't want to connect the dots. So, okay, yeah, those are the good days when we got to connect the dots. Those are behind us now. The good days are behind us. Okay, so they give us our x value of 310 watts. Could we use our equation to find y? You don't have to. There's no list given. But they gave us an equation. Okay, so you could put that equation into your calculator. You don't have to, or like into the y1. Could we well, how else could we find our y value given x is 310? Just sub in the 310. So let's sub in 310 for wherever we see x. Okay, so we're going to sub in 310. So y equals this ugly thing, 0.000000024 times 310 cubed plus 0.00193202 310 squared. How, the cube button, when we type this in, this equation on top, just put power hat 3.
Are you gonna put math?
Hat 3. Or math 3, yeah.
So can we just put that whole equation on the top and the y?
Yeah. And then just go
And then find it?
find the value, yeah. They're just as easy either way. Yeah. Okay, then we have minus 0.224951 times 310 plus 104.82707,619. So can somebody type this in? 149? Is anyone going to argue with that? No. Sure, because you can type this in if you really want to. Yeah, 149? Okay, so 149, and that's beats per minute. You need 149 beats per minute. Okay, use the curve of best fit. Does it say pit? It does. Use the curve of best pit to estimate the athlete's power. So we're just estimating now. So there's a difference between estimating. If I asked for you to use the curve, the regression equation, we'd have to go y2 equals and find intersection. This one we're just going to estimate. So so we have 130 beats per minute. Yeah, so if it says estimate, oh, I went too far. Look at that line. Okay, it estimates to about 240. It's an estimate, so there's a range of answers I'll accept. 149. So approximately. So notice the difference between that word estimate. So you can only use the graph like that if it says estimate. Okay. All right. This is fun. One more page and we're done. Done this unit. Yeah. Yep. Okay. So here you go. Can you start by entering this into your list while you wait? How do we do that again? Got it? Maybe I'll go undo then. So right? That's what I want to do. Okay, are we having a race here? That. Don't delete. Push clear. 1, 2, 3, 4, 5. Trying to be too. Okay, so that's the first step.
Wait, how do you get the y again?
Zoom 9.
Yeah, I pressed zoom 9.
Okay.
But I have the line.
Oh, we have to put it in. Oh, go to.
How do you put it in?
We're gonna put that in after. The reason why we're not doing it yet is we have to figure out which regression we're gonna use.
Oh, okay.
Right, with the R² value. So which one's best? Now this graph, it says describe the characteristics of this graph. What's the characteristics of this graph? It looks quadratic or could be cubic because both are curved. Could be, right? So how we would describe the characteristics is that it's increasing then decreasing. So it's curved because it's increasing then decreasing. Yeah. List, stat. How to get rid of these? Push up, clear, and then down. So just go up, push the clear button.
I was trying to do the clear all list.
I'll let you. Okay. Okay, so in this question, I'm telling you which regression to do, but how do we figure out which one's best? You do them both, right? In this case, you don't have to do linear. There's no way this will be linear. It's curved. So then we go stat, calc, and we're going to do both of them, number 5, and number 6. And we look at the R-squared value. So R-squared here is 0.999, and stat calc 6 is point. So technically cubic is better, but then I ask you to do quadratic. Okay. So if I don't tell you, that's when you have to use the R-squared value and use the best one. If I tell you, then you don't have to guess, right? You don't have to figure that out. You can just go straight to figuring out the quadratic regression. So let's do the quadratic regression again together. Stat, calc, 5. How do we put into Y1? Bars. Y bars. Enter, enter, enter at that point. Okay. So the first question asks you to write the regression equation. So we're going to write that down now. So our answer for this would be y equals, and let's go to 2 decimal places here, negative 10.07x squared. So it's telling you the a value here, right, is this. X squared plus the b value is this. X, and then the c value plus 11. So that's our regression equation. Okay? Everyone got that down? Yep, nope. Good to go? This is the regression equation. So it asked me to write out the regression equation. So the equation, if you look here, it's ax squared plus bx plus c. Yeah. Yeah, it gives it to you above, and then it just tells you to insert this is the a value, this is the b value, and this is the c value. Yeah. It is fun. Okay, so zoom 9. And your curve will also have the line automatically through it because we already did y1. So we did vars, y vars, enter, enter, enter. Yeah? Okay, just 1 sec. All right, can you answer the next 3 questions? Those A, B, C there. Question? We have our x values and we want the given y values. Now, if you're one way you can do it, I'm going to go back to the probably the easier way, is second trace value. Because then you don't have to switch between graphs. And then push 0, enter. Now, if it gives you invalid in your windows, you need to zoom out. It can't see it. It says invalid. So because we need to zoom out or change our windows. If you go to Windows, you can either push the zoom. So notice my x is starting at 0.6, and we want the 0 value. So that's why you could either zoom out, that's valid, or you can just change your own windows. So the y when x is these 3 values. Okay? Okay? So now that I've changed my windows, you might have pushed zoom out. So zoom 3, enter. Now try going second trace 1 for value and put in our 0. Did it work this time? It should work the second time. Now that you zoomed out. Enter. Or 0, enter. Okay, guys. If you're getting an error, a lot of your graphs look like this. You have to zoom out because I can't see it. Oops. Zoom, 3, enter. And most of yours looks like this. You have to zoom out. Okay, so your graph should look like this. Okay, now when you go second trace value and put in x is 0, it'll give you your answer. So 11 meters. And you can do all three now. So second trace value, I'm going to put in x is 2.5. So 76.575. And the last one, 4.5 seconds. Second trace, 1, 4.5, enter. 38.39. Okay? Now, when did the ball hit the ground? How do we do that? What's 0? Y is equal to 0. So there's two ways to solve this. The first way you can go is set y2 to 0. And then find what? Find intersection. The other way is you can use second trace or go into calculate. And number 2 is called the zeros but. Remember the zeros, x-intercepts? Both are the same. So do the first method. So y2 is 0, graph. Now there's 2's, you can't actually see it because it's going over the x-axis. Second trace, number 5 for intersect. Make sure you're on the right one, right? Because we don't want a negative time. It's not possible. So go over there, push enter 3 times, and it gives you 5.31 seconds. So you don't want this one, you want that intersect. Okay? The other way, okay, the other way, which is just as valid, is find the 0, right? This is an x-intercept. So second trace, number 2 is 0. Remember we did these last year? We did left side, enter. Did you do these with Mr. Trimble as well? Right side, enter, and then enter. 5.31. Okay? Both the same. Good old Trimble. Okay, so that's the lesson finally. We are done. It's a long lesson,